Good afternoon and a very warm welcome to all. Our today's topic for the webinar is National Green Hydrogen Mission, which is recently approved by the Cabinet. Decarbonizing India, achieving net zero vision is the ultimate aim of the mission. Let us listen to our eminent speakers, what the mission holds for hydrogen industry, what are the opportunities and how much investment required in achieving the targets, what are the how much skilled power will be required and what are the programs for developing these skills. I'll just inform our audience a basic information that all the mics and cameras have been disabled. Please type in your question in chat box, and if you want to reach us, please mail us or call on mobile. The session will be followed by question and answers. And you have our contact details. You can mail, WhatsApp or call on us. So I would just like to inform, today we have our speakers, Dr. Devesh Patra, Dr. Shambhu Ratan Avasthi, Ms. Pranjali Sharma and Mr. Manoj Pal. I'll just give a brief introduction of our speakers and then we can move on. Dr. Devesh Patra, he is Program Director of IESD, Hydrogen Programs. He is former Executive Director of BPCL. Dr. Patra had 2 years in stint with the Department of Economics Analysis and Policy, Reserve Bank of India at Mumbai. He has authored 3 books and 45 published papers. He has extensively worked in area of petroeconomics and energy transition. He is a fellow Energy Institute, London. I'll just introduce Mr. Shambhu Ratan Avasthi. He is a former General Manager of BHEL, former Director of Rabindranath Tagore University. He has published and presented over 100 papers. He has written some books who have been awarded. His book, Practical Aspects of Hydro Generator in Hindi, is awarded by Ministry of Science and Technology. Another renewable energy book is awarded by Ministry of Renewable Energy. Other books are Wind Power, Renewable Energy for Small and Micro Hydro Projects. There are 3 books on renewable energy are under publication. Welcome, Dr. Avasthi. Ms. Pranjali Sharma. She is a scientist in Humble Hydrogen's high and ultra pressure storage division, holds 2 patents on advanced hydrogen high pressure composite storage, has 5 years experience of innovating on high pressure gaseous hydrogen cylinders for fuel cell vehicles. She was the project manager of the development of 350 bar storage solution for the R&D of IOCL in association with IIT Kharagpur. She has 5 publications and she is author of to a book chapter. Mr. Manoj Kumar Pal is our next speaker. Mr. Pal is MTech in Mechanical Engineering with 14 years of experience in project management in EPC projects across various industries. He is actively working in the hydrogen and renewable energy, and he is member of PMI USA and SEAM India. I welcome all the speakers. And we can start with Dr. Patra. And I would just like to inform, ISD is with Indian Energy Week and Dr. Patra is presenting a paper on 8th of February around 10 a.m. So all are invited, they can register and listen to him. Over to Dr. Patra.
Good afternoon, my dear participants. Thanks to Manju for the introduction of the session as well as introductions of the speakers. Friends, we are witness to a momentous time in the history of India's energy transition. And last week, Government of India Cabinet has approved the National Green Hydrogen Mission. And within a week, IESD is here to present you a webinar and thus creating awareness dissemination of knowledge, being a knowledge and innovation platform. Now, there are my three panelists are there. They will cover different. Each one of us will cover different aspects of this mission. Now, my session will cover the context, which will essentially say what all has happened in the hydrogen regulatory space and policy space so far in India. And I'll also cover the features of the mission, basically to say what all the mission statement provides and what are the content and coverage. And I'll also kind of touch upon what is the way forward, means what are the likely actions to follow. Now, one underlying objective of this webinar is to reach out that all stakeholders to be aware of the potential, possibilities, and the risks, and then will contribute to the hydrogen economy as it unfolds to meet the goal of decarbonization, energy security, and socio-economic development of our country. Now, the first time, Honorable Prime Minister of India laid out the plan for green hydrogen at the third renewable energy investor, and that happened in November 2020. Then in February 21, Union Finance Minister in her budget speech made a provision for some sum for this national hydrogen mission. Then in August 21, Honorable Prime Minister again, he announced this national hydrogen mission in his Independence Day speech. Last year on 17th of February, Government of India unveiled India's green hydrogen policy under this national hydrogen mission, and that document was the first policy document under this mission. Now, if we have to understand this mission, before that, let us understand some of the theoretical structure of this mission. First thing, a country needs decarbonized, reliable, and cost-effective energy system. Now, adoption of green hydrogen is a part of the energy transition process of the country. And energy transition is largely influenced by economy-wide policies. A broad base of support can create enabling environment for green hydrogen actors to provide their value to the whole energy and social system. So in this transition process of green energy, there are areas of low priority, there are areas of high priority, and the square that comes on the right hand side on the top of this graph is all the areas of high priority, and that is addressed by hydrogen. And the sectors which are uppermost or top priorities are the industries, chemicals and refineries, then steel, then international shipping, then long-haul aviation, and then comes long-haul trucks and high-temperature heating. Now, everything that we talk of energy, particularly the energy transition leading up to the adoption of hydrogen, is contingent upon some innovations. Now, innovations has to take place in the space of technology and then get translated into infrastructure. Innovation has to be there in market design and regulation. Innovation has to be there in system planning and operation. And innovation has to be there in business model. For example, in the space of technology innovation, there comes electrolyzer technology, hydrogen storage, digitalization for renewables, and hydrocarbon production forecast. And so on. In coming to market design, we have to have a flexible power purchase agreement, regulatory sandboxes and testing platforms, and then updating electrical and gas grid codes. And like that, it goes on. There are many areas where this innovation has to work. So the challenges are there on the across the value chain of the hydrogen, that is production, storage, transport, distribution, and end-use application. And the solutions are primarily two. One is innovation, second is policy. And so far, what has happened in India is that it is a part of the bigger energy transition picture. And the shift to hydrogen has to take place as a support to India's energy security. And India is in the league of 30 countries in the world where hydrogen strategies have been outlined. And India has declared its ambition to become an exporter of hydrogen to countries like Japan, South Korea, and Europe. So overall, a competitive value space has been created in the manufacturing and commercial area for hydrogen, in which corporates, R&D setup, and foreign collaboration are vying with each other to step in. Number of companies, private and public, have committed their investment decisions, and all these have been listed here. Many of them are largely known to you all. Therefore, I am not going one by one. However, it is listed here. But with this kind of status, as we find in India, certain things are being waited upon. For example, a policy landscape is being expected. Incentive structure is being expected. Demand priming by the government is being waited upon. Technology innovation through research, development, demonstration, and deployment, that is the country is waiting for. And ecosystem for cost reduction, the country is waiting for. And then the collaboration and the trade. So all these resulting in investments in hydrogen value chain, as well as in application, and this the country was waiting for. And when the country was waiting for all these, then came National Green Hydrogen Mission 2023. The mission has three components. One is the mission is helping to create demand. The mission is helping to incentivize supply. And there are some ecosystems, some key enablers mission is facilitating. Now, what is the budget outlay? 17,400 crores has been kind of allotted for strategic intervention for green hydrogen transition program. And there are two programs basically, which is given on this left-hand side box on the bottom of the slide. One, domestic manufacturing of electrolyzers for 5 years, and then the production of green hydrogen. Then some pilot projects, particularly in the hard to abate industries like refining, steel, cement, shipping, and production pathways. There have been some budgets of 1,466 crores. And then R&D, that is, will be done under strategic hydrogen innovation partnership with a PPP model, and 400 crores have been allotted. And then some miscellaneous other components, 388, 19,744 crores of rupees have been allotted under this mission by the cabinet decision. Now, MNRE will formulate detailed guideline for implementation of the respective components. Mission has also outlined a timeline, what will be done by what time. First 2 years, 22 to 24, it is an initiation stage. 25, 26, some activities have been listed as preparatory stage, and then 26 to 30, the implementation stage. So everything put together, the country has to see that the policy has to catalyze to investment, which means 19,744 crores when it is spent by the government is expected to generate an investment of 800,000 crores. And that will happen by scaling up of consumption, innovative technology, and reducing cost. And what is expected out of this mission is that 5 million metric ton of green hydrogen will be produced in association with the renewable energy capacity of 125 gigawatt. And then, as I said, 8 lakhs rupees growth investment is likely to happen. 6 lakhs job is likely to be created, and so much of fossil fuel import will be reduced, and so much of greenhouse gas emission will be reduced. Now, all these all these working, some backup working also have been given, that this 5 million ton greenhouse hydrogen production would require 32 gigawatt of electrolyzer capacity, which will consume 115 million liter per day of water. And similarly, this also is contingent upon 90 gigawatt of solar, 38 gigawatt of wind power, and that will use 340,000 acres of land. And then carbon dioxide emission, etc., reduction, and all these things, all the backup calculation. Now, what is way forward? Way forward is that an enabling policy environment framework will be developed to sustain the establishment of green hydrogen ecosystem. A robust standards and regulation framework will also be developed. A public-private partnership framework for strategic hydrogen innovation partnership will be facilitated under the mission. R&D projects will be goal-oriented, time-bound, and suitably scaled up to develop globally competitive technologies. A coordinated skill development program will also be undertaken under the mission, and mandatory green hydrogen consumption would perhaps be set for fertilizer units, petroleum refineries, and city gas distribution network. Now, the significance of these things is that the future outcome of this mission relies a lot on crafting of these details and guiding the ecosystem as it unfolds. And there are all ministries, departments, state governments, etc., etc. They will coordinate under the overall nodal agency, that is Ministry of New and Renewable Energy, that is MNRE. And there is a governance structure which is there in the part of the report. Now, specific actions that are likely to follow, that in the next 3 to 4 months, government may invite competitive bids for subsidies, and bids will be invited for setting up of 2 green hydrogen manufacturing and utilization hubs, that is fertilizer and steel plants and factories for making electrolyzers. And the plan aims at using green hydrogen in fertilizer and steel production in place of gray hydrogen, blending into urban gas supply, that is CGD, and use in transportation. Steel plant using 100% green hydrogen also will be set up. Government may invite bid within 3 to 4 months and may award the contract within a year. It is likely that in the upcoming budget, government will allocate more capital under PLI scheme for domestic manufacturing of electrolyzers. And until electrolyzers are produced in large scale, there may be concessional duties on import of next few years, and there could be a total waiver of duty on electrolyzers. Thank you from my side, and others panelists will follow. Thanks for patient listening.
Thank you, sir. Now I will request Dr. Awasthi to start, please. डॉक्टर अवस्थी आप स्टार्ट कर सकते हैं.
म्यूट, ही इज अनम्यूट.
अनम्यूट कर देना.
Yeah.
Good afternoon to everyone. Sources and mechanism of hydrogen production, renewables, water, and application of fuel cells. These are the topics that I will cover in my this speech. Next. You know, there was a global investors meet at Indore on 11th. It was inaugurated by our Prime Minister. He especially mentioned and emphasized for investment in green hydrogen. Next. This shows the importance, and this shows there are tremendous, as Dr. Patra has already presented, tremendous scope in all the fields, whether it is consultancy or skill development or some sort of training or awareness program and operation, maintenance, installation, whatever you think of, there is a tremendous scope. Now, before going further, there are some point I will like to caution that hydrogen is well established as far as the industries are concerned, but now it is going in the public domain. So awareness is of great importance. Then leakage is a critical issue because it is colorless, odorless. So you cannot see, you cannot realize that it is leaking. So that is a challenge. It is the lightest transfer, so it moves up. This is plus point. It moves up in the atmosphere. So we may put at the top of, if it is an enclosed system, some sort of detector to detect it. So that is, embrittlement is posing a great challenge. It is very challenging because existing infrastructure of CNG, PNG, etc., that cannot be used. A dedicated infrastructure has to be developed, but there is option that some limited way we can do the blending with CNG and PNG. And of course, it may be limited to around some 17% or so. And till infrastructure gets developed for hydrogen, there is an option that we may take the route of green ammonia. Green ammonia is important. It is part of the policy also, which was issued in February. Now I come to sources. You know, we are all aware of these sources: fossil fuel, coal, crude oil, and renewables, and biomass, and of course nuclear. These are the main. Next. This production mechanism. So I have just listed here, but better we go to next slide. From there I will start explaining also. So next, please. Yes. Now, steam methane reformation process, this is almost 95 or even 96%. Globally, it is followed. This is the method of producing at present. So it is in two stages. First stage is the reformer reaction. Here, methane, CH4, and water generally in the form of steam. They go and they produce a syngas. Syngas is a mixture of carbon monoxide, CO, and hydrogen. And the next stage, we have to segregate them. So again, there is CO. We again induct some steam, water, and so that CO is converted into CO2, and hydrogen is there segregated out. This is the most commonly adopted everywhere throughout the world. Next. Next. This coal gas, no, previous. Coal gasification. In coal gasification, pulverized coal is used, which reacts with oxidant, I mean, some sort of maybe oxygen or some steam. And coal is converted into a very hot syngas. Syngas is again some mixture of mainly CO and hydrogen and CO2 and something else also. So again, here same process goes on, and syngas is then through the shift converter reactor. It has to be purified, and all impurities are to be removed. And if we make the provision of carbon capture also, then the hydrogen that we get, that is designated as blue hydrogen. Next. Biomass. We know biomass, what are these? So next, I will explain. Biomass gasification. Gasification method, we have just discussed coal gasification. It is similar, but when we get the syngas, then it contains a lot of hydrocarbon gases and impurities and some particulate matters also. So there is one additional step as far as biomass gasification is concerned. The exercise step is that we reform hydrocarbons with catalyst to get clean syngas. And once syngas is available, then naturally we have to segregate CO2 or to be removed, and hydrogen we can get. That's all. This is the process. Next. Anaerobic digestion. This is something mostly we are well aware. We call it gower gas and all that. That plant, that sort of this phenomena takes place. It takes place in the absence of air, and it produces high thin content. So this biogas can be used for different applications, even for cooking and all that, for domestic and lighting and all that. But a very important one is from digestate. What we get, that is very useful fertilizer. At the same time, it can be used for soil conditioning also. This biomass, and this is very important in Indian context, because the Indian economy is dominated by this agriculture sector. Okay, next please. I would like to mention the main problem with our this biogas, biomass waste conversions and all that. These processes are very slow. We need large scale, this production of hydrogen and green hydrogen, and huge quantity and at fast rate. So a lot of research is going on from various institutions. So, but I would like to mention that core infrastructure, USA, they have used organic waste and closed loop carbon negative pyrolysis process. And they've already demonstrated this project by operating it for 1 year. It is in California. So this is some development and encouraging development. And they claim this is very, 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 very pure hydrogen they are getting from it. Anyway, next. Nuclear plant, we know. This is, they are basically this and thermal, they take care of this load in our system. So, what we get energy to form, one is electricity, and another one is this heat. These two forms are available. And next, and these two forms of the energy. Hello?
So we can hear you. Please continue.
So this is used for electrolysis. Now there are three options. If we use only electrical power, then what we get is pink hydrogen. If we use only heat power, high heat temperature electrolysis, then it is red hydrogen. And when it is a mix of these two energies, then we call it purple hydrogen. Next. Renewals we know, and as Dr. Patra has mentioned, 125 gigawatt, they are to be added by 2030. So solar and wind and hydro is very important. I will like to share my views that everywhere we are finding, people are mentioning, and in documents also and papers, solar and wind. But hydro is not less important. It is very, very important. It forms a part of water management. That is one thing. And now floating systems are coming up very fast. And solar, what are the inputs required? Let us see. Inputs required are electricity and water. And when it is a solar PV system in a floating mode, then we are getting unique advantage. Both the things are available. Both the inputs are available then and there. Another advantage, very large these water bodies, if you spread all these our floating type of systems, then evaporation losses are also reduced substantially. That is another great advantage. Anyway, go next. You will be, pleased to know that biggest floating type of solar PV system, it is coming up and it is expected in this year. It is in Omkareshwar, Madhya Pradesh. So there is already a hydropower project, 8 into 65 megawatts, 600 megawatt. It is coming on Nanda River on the investment of 3,000 crores rupees, and it will occupy the area of 100 square kilometers. Next. Offshore, we do not have even a single turbine which is operational as on date. And there seems to be great potential in the context of hydrogen also. So here I would like to mention that Reliance is taking initiative. They have taken some decision, and to gain some experience, to start with, they will go with 5 megawatt wind turbine, and it will be installed in the sea waters of Gujarat. A pact has been signed with Skisdal, Denmark, for technology development and hydrogen electrolyzer manufacturing. So this is something very important, great initiative. Next. Here, this in the context of electrolyzer, I just want to mention that people always talk about electrolyzer only, what about BOP and all that. So I will just like to give a small explanation that so many things are involved. If you talk of water, it has to be demineralized water, then collection, purification, drying, compression of hydrogen, and so on. And if you are drawing the power from the utility grid, then transformers require rectifiers, control systems. So I would like to state that all these things we are competent enough to manufacture and design and everything we can do. So there is no problem in these all BOP areas. But electrolyzer, yes, as per the state of the art, and we have to go in a big way. So that's why there is maximum emphasis on the manufacture of electrolyzers indigenously. So this is the point. And of course, oxygen is the byproduct in the electrolysis process. So huge amount of hydrogen is available. So this can be sold and utilized, and it can also improve the economic viability of the hydrogen generation production project. Next. Water I have mentioned, about 10 liters per kg of water is required. And there are many sources, I was just talking about the reservoirs, dams are built and all those, and most of the projects are irrigation dams. Another is, during this, our Azadi Ka Amrit Mahotsav, so Amrit Sarovars are being built around the country, and every district has to go for some 75 Amrit Sarovars. So dedicated for hydrogen production also, similar sort of some Sarovar can be developed. And Dr. Rajan Singh, he is also known as Waterman of India. He has revived so many rivers and tanks. So in Rajasthan, he has worked basically in Rajasthan. So all these resources, whatsoever suits depending on the location and all that. And seawater, it is a great news that IIT Madras, they have developed technology for the use of seawater for the electrolysis. It is something very, landmark, this research. Next. This is the first Amrit Sarovar, just what beautifully they are designed and all that. So next. Fuel cell applications, there are many applications, inputs to be given to fuel cells. Fuel cells, it is a reverse of this electrolyzer. So input are to be given are this hydrogen and oxygen are generally air, from that it is run. And output we get in the form of electrical power, heat and water. There are minor and so many applications, but I will just speak about this generation part and transport sector. Next. Transport sector, next. You just see the energy chain, energy conversion chain. You are starting from the electrical energy. We are seeing the wind turbine, going for electrolysis, compression, storage, and then again feeding to fuel cell in this transport vehicle. And their fuel cell is giving electricity to drive the electric motor. So this is the energy conversion chain. There are so many benefits of fuel cells, and it is zero emissions and efficient, quiet, and long distances with fast refueling. They are the great advantages compared to battery and other systems. Next.
So can we finish in next 2 minutes, please?
Yeah.
There are two other
Next.
speakers.
Next. This is, Auto Expo also, this Noida, this NQ, this MG Motors, they have displayed this hydrogen car. And this is some different car I am showing. This is the arrangement what is shown here. Different, and some batteries are also provided as a backup to take care of excess power and all that. Next. This is the first hydrogen bus based on this PEM. It was in Pune. And in Auto Expo, which is going on right now, Tata Motors have probably displayed their hydrogen bus and truck. Next. This is the train in Germany, 2018. This was the first train, and now they are operating 14 hydrogen trains. And here you please note that this hydrogen tank is at the top roof, so that in case of any leakage, the hydrogen goes up in the air. Next. In India, there are eight numbers heritage trains and routes. So all they will be converted into hydrogen, these trains routes within 2 years. And another is Vande Metro. The first train will be starting this year only. And then we will join another 3 countries, Germany, China, France. India will become the 4th such country to have such indigenous development. Next. Again, this shipping sector, so this at Cochin shipyard, we are this manufacturing indigenously this kind of ship, hydrogen driven. Next. And this is, of course, liquid hydrogen. It is used for a long time by NASA and for launching support. You are seeing the storage also. Then last one is this power generation. So next. Here you please notice that world's largest one is 78 megawatt, this power plant in Korea, and they are using phosphoric acid fuel cell, phosphoric acid. Next. In India, first 10 kg, we are all aware that Jorhat pump station, Assam, Oil India has installed this one. This is a pure hydrogen, this pilot plant. It was commissioned in 22. So it is having this 500 kilowatt solar PV and 100 kilowatt anion exchange membrane electrolyzer. This is the first time in India this type of this system is used. Next. NTPC Simhadri. They are having something very unique. Totally microgrid connected standalone system pilot plant with 25 megawatt of floating solar PV and high pressure storage. And solid oxide type of this electrolyzers have been used, and fuel cell. It is a complete system. So what they will do, they will produce this hydrogen, store. So storage is also there, high pressure storage, and there will not be any grid supply. So they will supply to their guest house this power by converting through the fuel cell, and they will gain this experience for some time, and it is some sort of a pilot project, and then they will go in a big way in this area. Okay, next. So these are my contact details. You are welcome to contact me. Okay, thank you.
Thank you, Avasti sir. Now I will invite Ms. Pranjali to speak on.
Am I audible?
Yeah, we can hear you.
So As Dr. Avasti has already discussed about various ways in which hydrogen can be produced, I'll be talking about techniques in which it can be stored and distributed to the utilization sites. So this is the outline of my presentation. So we'll start with how to make India a global hub for producing and exporting green hydrogen. So with this, we need low-cost systems for producing, distributing, and storing hydrogen. Along with this, we also need utilization sites to have fuel cells, which will be low cost, have high lifetime, and have high energy efficiencies too. So we start with classifying the utilization sites. The utilization sites are categorized into two broad categories. Industries require stationary storage, while the automobile sector requires mobile storage. For stationary storage, we mainly focus on like gaining the required performance of the storage system and to have a system which has least cost. But for automobile sector, we have two major objectives: low cost, low weight, and both of these are to be achieved without compromising with the safety of the vessel. So for this, we start with developing the systems. The major technical challenges while developing the system are in the form of its design, manufacturing technique, and the testing facility. So the design mainly depends on the working pressure up till which the distribution or storage system has to be utilized. And based on that, material, geometry, working pressure, and all other properties are optimized. For stationary storage, we optimize them such that the overall cost of the system is minimum. But for mobile storage, we want the material, geometry, the composite properties, and all the other parameters to be aligned in a way to have an overall system with least cost, weight, and achieving the required performance. So the performance of these systems is tested in the form of their burst pressure, their fatigue life, that is the operational life, the response to fire, and other preliminary tests which test their performance when dropping from high heights or when injecting with a bullet or something similar. So based on this, as an approach, we can start with the current CNG cylinders which are available in the market, which already have the standards, which are already passed as per the certification standards. We use materials and we store hydrogen blended CNG into it. So the issue with hydrogen is that it reacts with the inner surface of the materials and corrodes the inner surface of these plants. So this corrosion rate depends on the partial pressure of hydrogen which is present in that mixture. If we just reduce the percentage of hydrogen or we reduce the overall working pressure of the gas, then in those cases, we can simply store HCNG blends into the existing CNG cylinders and slowly transition ourselves into a pure green hydrogen economy. So therefore, if we once check the partial pressure up to the safety limits, it is possible to deploy the cylinders. Now we have different storage systems which are commonly used for storing hydrogen. Compressed gas being the most well-developed technique is adopted in the global markets. So the overall applications are classified into two broad categories. Industrials are suitable for stationary storage, while transportation is preferred with mobile storage efficiency. So for industries, the ones highlighted in blue have large scale consumption of hydrogen. So in those cases, we simply deploy an electrolyzer on site. We produce hydrogen and this hydrogen is directly used in the plant itself. If the required pressure for hydrogen is higher, then we use compressors to like bring hydrogen to this operating pressure, or else we directly use it for other applications. In industries which require hydrogen at comparatively lower consumption rates, we can just add storage systems so that they can act as buffer solutions. As soon as they get finished, we can refill them whenever required. So this is the schematic as seen here. We have electrolyzer producing hydrogen at 30 to 40 bars. This hydrogen can directly be stored in a type 1 tank, or a compressor can be used to pressurize this hydrogen and store into buffer systems. This is the multiple stack cylinder pack, which is being like manufactured at our facility. In this, we can see many type 1 cylinders are stacked together. They are fixed with valves, and manifolds are placed onto it along with a home service line. So this entire system can act as a portable hydrogen dispensing station, and it's comparatively safer as compared to this direct tank, because this has more number of valves and PPRD devices. Now, if we want to use the same system for mobile applications, we'll just have to replace these type 1 cylinders with type 4 cylinders. As seen, the difference in the weight is 110 kgs is the weight of a single cylinder for 200 bar pressure and 100 liters of volume. And for the same pressure and volume, the type 4 cylinder will only weigh 31 kgs. We can see this entire stack around 1400 kgs in weight. If we go for type 4 cylinders, then this weight is significantly lower. So therefore, we need to work on indigenously developing type 3, type 4 hydrogen plants, so that we can further expand this hydrogen storage systems to the mobile sector. These are the various components involved for manufacturing type 3, type 4 tanks. Various phases of these are not yet available in India for indigenous production. For example, liners are to be imported. We don't get the adequate quality which we require here. When carbon fibers are not available in India, resins are well available, binding facilities are there, but then again, testing facilities are not well developed to test the cylinder as per all the tests which are mentioned for the cylinder certification. Once we have indigenous facilities for developing type 3 and type 4 tanks, similar containers, as explained in the last slide, can be used by starting various type 3, type 4 cylinders together in 10 feet, 20 feet, and 40 feet containers. We'll just add all these cylinders together with manifolds and valves so that they can act as portable dispensing stations. So for locations which are quite remote and don't require hydrogen dispensing so frequently, we can directly use them instead of implanting an entire dispensing station there. These individual cylinders can also be used in these vehicles. For example, the cylinder with higher length can be used in trains, the shorter lengths perfectly fit in cars, and the ones which vertically fit in these containers fit in trucks and buses for heavy duty applications. So once we develop the technology for manufacturing these type 3, type 4 cylinders indigenously in India, then we can simply solve two major challenges. One is dispensing the hydrogen from the production site to the dispensing station, and the other one is for direct deployments in automobile industry. So this is the way forward for green hydrogen storage and distribution systems. We just need to complete this entire roadmap, that is starting from hydrogen production systems up till the dispensing station. This requires development of pipelines, then the containers which will carry type 3, type 4 cylinders from one side to another. And the final bit would be the dispensing station for storing hydrogen and dispensing it into the automobile which operate on hydrogen. This dispensing station also use high pressure buffer storage systems, which are mainly comprised of type 4 type 1 cylinders, all attached together using proper manifolds. So this high pressure buffer system is it is really possible to make it indigenously in India right now. But this type 3, type 4 cylinder is something which we need to work on further. For this, we need indigenous facilities for manufacturing the liners, manufacturing technique for binding the composite cylinders, and also certified testing agency for ensuring the safety of the tanks for commercial deployments. Once we achieve all these objectives, then developing low-cost, lightweight composite cylinders would really be easy. And thus, green hydrogen could really be utilized in the Indian market itself to fulfill all the energy demands. That's all. Thank you. So I'll give over
Thank
to...
you. Thank you, Pranjali. Now I would invite Mr. Manoj Kumar Pal.
Hello, Good afternoon. Uh, Hello, my voice is audible?
Yes, yes.
Okay. So, yes, uh, good afternoon to everyone. This is Manoj. Ma'am, already on National Green Hydrogen Mission, Mr. Patra has covered. So we'll go on third slide.
This is fine. We are starting.
Yes, we can go on next slide. The object is already covered. Yes, ma'am. Next slide. Okay, so already other three panelists have covered on the technical and aspects of the hydrogen, as well as where on the National Green Hydrogen Mission, what is there in that mission. So what I'm going to cover now, where we are and what we wanted to achieve. So, and why hydrogen, first of all? So, first of all, the story started since when the Conference of Parties 2015, when all the countries have agreed to limit our temperature rise to 1.5 degree from the pre-industrial level. And from that point, we started uh, working on the clean energies. And if we wanted to meet that 1.5 degree temperature rise. So our by 2050, our energy mixture, like hydrogen consumption in our overall energy should be at least 15%. But since 2015 to 2023, we have not done much. So right now we are lagging, and we need to do many more things to achieve this target. If I will go by the DNV report. Uh, we are just at the 0.5 percentage of these 15 percentage. So that is where, and why hydrogen? Because hydrogen is a clean medium. When it burns, only there will be the emission of the water. There won't be any greenhouse gases emission, and that will limit whatever the global warming and other things which are happening because of the greenhouse gases, that will be eliminated, or I can say reduced. Now, there are many times people ask why we already we are in green hydrogen, we are going to use electricity, and again the same electricity we are going to consume in the other sectors. So there are many sectors which are we call as hard to abate sectors. There we cannot use electricity directly. So that's the reason we first whatever the renewable energies we convert into some other source like hydrogen, which is a clean medium, and then that the hydrogen will be used as a feedstock, otherwise as an energy source in those industries. And if we wanted to achieve our net zero emission, so by 2030 we have to go produce at least 175 metric tons per year green hydrogen. Yes, ma'am, next slide. This is already covered by Mr. Ravasti, so we'll go to the next slide. Yes. So when we are going to produce green hydrogen, so we should not do whatever the renewable energies which we are going to uh, manufacture for our uses, that should not be uh, bypassed, otherwise used for the generation of the green hydrogen. Only the surplus renewable energies, if that will be used, then that we will call as a whatever the production we are going to do as a hydrogen, that will green hydrogen. Otherwise what we'll do, we are going to instead of fulfilling our daily needs, we will by renewable energies, we'll pass that to industries for the generation of the green hydrogen. And another way, we are going to use the fossil fuel as a source of medium to generate electricity. Ma'am, next slide. So in terms of in India, where we are right till now, by end of last year, there was a total installed capacity was 409 gigawatt. And out of those 409, there was 119 gigawatt as a renewable energy. And in the National Green Hydrogen Mission, India has committed to produce 125 gigawatt renewable energy for the green hydrogen. That means whatever the installed capacity of the renewable energy today we have, more than that we need for the generation of the green hydrogen. And for that, the national electricity has already drafted plan, that is it not issued. As per that plan, we need to generate 865 gigawatt of electricity by 2031 and 32. Earlier, till last year, it was 500. I mean, in India's mission was to generate 500 gigawatts by 2030. But now we are already late, so that is a plan was postponed by 2 years. Now we are going to generate by 2031 and 32. That means 2 year afterwards. Yes, ma'am. Next slide. So the renewable energies, since in India we have already identified the locations, and if the problem is already known, so anyone can work on that, and that's what government of India is doing. They have already identified location. They have already identified what is the renewable energy is required to generate a green hydrogen, and we have now 8 years of timeline to produce 125 gigawatts. Now, next is electrolyzers. So there are many types of electrolyzers available in the market, but only right now, alkaline electrolysis and polymer electrolyte (PM) are in commercialized in the market, and other electrolyzer. Ma'am, previous slide. Others electrolyzers like AEM and solid oxide. AEM is at prototype level. That has AEM. I mean, last year it's from type 4 to type 5 to type 6. It has passed type small prototype to large prototype, and SOEC is at demonstration level. So right now, only we have alkaline and polymer electrolyte membrane electrolyzers available in the market to generate hydrogen. Yes, ma'am. Next slide. So total till now, the installed capacity of electrolyzers is 8 gigawatt, and that we need to reach up to 700 gigawatt by 2030 to generate green hydrogen to meet the net zero emission. That means to generate 175 metric tons of hydrogen. So, and whatever the plant projects are in pipeline, otherwise which are projects are already completed, as per that we are able to achieve hardly 240 gigawatts of by 2030. So still there is a gap of 500 gigawatts, and that is the opportunity. And because when there is some roadblocks, so there now the industries can generate an opportunities by grabbing these and installing them mega factories. Yes, ma'am. Next slide. So if we go by the current capex and opex of these electrolyzers, so from capex point of view, the capex is like cost of electrolyzers, and opex is the electricity which is required in by renewable energy. So right now the proton exchange membrane and SOEC, if so SOEC on this, the more innovations and technology advancement is required to improve the efficiency, reliability, as well as their cost. Yes, ma'am. Next slide. Yes. So now, since we have figured out what is the gaps in meeting our national green hydrogen mission. So we need to work to, first of all, produce renewable energy. Second is to work on the electrolyzers to install other mega factories, otherwise to generate produce electrolyzers. And if we go by the current demand of the electrolyzers, so in India itself, we have forecasted around 60 to 70 gigawatt electrolyzer against the current install of 8 gigawatt. And apart from India, there are so many other countries. They are already working on their hydrogen missions there. And so total, as we have the 700 gigawatts of requirement. So we need to work on the improving the first of all, reducing the cost of these electrolyzers, increasing the efficiency, improving the reliability. And for that, the government has already identified some of the funds, but still all the public-private partnership, they need to work together to improvise the equipment efficiency. Yes, ma'am. Next slide. This
No.
transportation and storage is already covered by. Yes, ma'am. Next slide.
Can we just finish in next 2 minutes?
Yes.
Okay.
Next slide, ma'am. It is already covered. Yes. So what is way forward? So India has a huge opportunity to become the global hub for the electrolyzers, as well as now already industries, all the OEMs, they have started doing some R&D works by, as mentioned by Mr. Avasti, some prototypes. Otherwise, by purchasing its individual small capex, small capacity electrolyzers from other countries, and then trying to improvise by changing the materials, because the material which is required for the manufacturing of these are like those are even not available, and for that material also, like iridium, platinum. So those materials requirement needs to be changed to improve the reliability. So if we see today, the cost of the production of the green hydrogen is around 4 to 5 USD per kg, and that is far above than our targeted 1 to 2. So that entire by 2030, at least we have to be reduce the cost by improving the working on the renewable energy as well as the equipment to bring down at least up to 2 USD per kg. Yes, ma'am. Thank you.
Thank you, Mr. Manoj. Now we are going to take question and answers. So I'll just request all the speakers, the relevant questions being asked by the audience can take it. Patra sir will be asking the questions, please.
Thank you, my panelists, Dr. Avasti, Dr. Pranjali, and Manoj, for their very elaborate and minute and very intelligent kind of work they have done and presented to this webinar. And thanks, audience. We have some questions. Let me go one by one. Question from Lavanya. Is complete mission document available in open domain? Yes, complete document today is available in public domain. I have got to view it today. Perhaps it will be in MNRE site or somewhere else, but it is available, the complete document. Now, question from Gomati. What are the new pipeline projects on hydrogen coming up? To the best of my knowledge, no new pipeline on hydrogen or for hydrogen is coming up. What is instead being attempted is to blend hydrogen with natural gas and push it to the pipeline. If you look at the experience of other countries, they are also talking about repurposing the existing natural gas pipeline and to use it for hydrogen. So no new pipeline projects are not coming out. Can oil and gas and CGD sector employees apply for job in green energy sector? This is something related to job market and individual. One has to find a way. Pradeep Sharma is asking, will there be any PLI-like scheme for manufacturing of electrolyzers? Yes, it is being reported in the media that kind of PLI will come, including some government pronouncements, etc. is being there. So most likely it will come. Namami Sharma, how long of time will it take to become India self-reliable in green hydrogen? See, the demand for green hydrogen is open-ended as of now, though some estimates have been made and 5 MMT has been put in the mission document till 2030, but reliability is as time goes on, we will come to know, because as I have said in my presentation, the use of hydrogen is outcome of energy transition process that takes place. So demand is open-ended, supply, if it comes up, demand will catch up, subject to pricing and economics. Okay. What is the status of statutory guidelines for safety and handling of green hydrogen? Yes, standards and measures and testing processes are being done. And as and when hydrogen comes into application, green hydrogen, those things will be applicable. But currently also there are some standards internationally, DNV, etc., are available in the industry. Pradeep Sharma, is there any mandate for consumption of green hydrogen in refinery, petrochemical, fertilizer, or it is proposed, expected in due course? No, it is only expected, but then refineries have been advised, because refineries are mostly in the public sector, PSUs. So PSUs have been advised to, to make certain percentage of their hydrogen use only green hydrogen. But the question is not mandatory. Question is the industries are looking for economics, availability of green hydrogen, and their technical kind of preparedness to take it as a fuel or feed. So that process is on. It is just the beginning. Okay, that's all the question we had. We have answered them in full. Over to Manju.
Thank you, sir. And thank you, speakers and audience. And I'll just request the audience, still, if you have any questions, you can send it to us on mail and we can ask our speakers to reply. Our recording will be available on our website. Even the question answers will be available on the website. So you can very well see the complete recording. Thank you. Thank you very much.
Thank you very much. Bye-bye.